Hi folks, I wanted to go over this idea of graphing lines with you. Some of you missed class today and some of you said you've never done this before, so I want to just make sure we're clear. This is a skill you really should have seen last year and then COVID happened. It's super important though. You're going to be doing this pretty much for the rest of math, okay? First thing we're talking about here is just graphing lines given a slope and a y-intercept. The slope affects the slantedness of the line. Is it a really steep line? Is it a not so steep line? Does it go left, right? Does it go right, left? Is it horizontal or vertical? The slope is what affects that part of the line. The y-intercept reflects how far up or down that line is on the graph. So what we're going to do is we're going to put those two ideas together to come up with the unique line that has a y-intercept of 1 and a slope of 6/5. So what we do is we take that y-intercept first. The y-intercept is the point where the line crosses the y-axis. Well, this is the y-axis. It's crossing the y-axis at 1. So I'm going to go to 1 on the y-axis, positive 1, and put a point there. Now I know that the line is going to somehow go through that point. Maybe it looks like this. Maybe it looks like this. Going through that point, maybe it looks like this. I don't know, but I know it goes through that point. What's going to determine what the line looks like now is that slope. So the slope is 6/5. Slope is what we call rise over run, or the change in the y over the change in the x. And what we do is from that point, the y-intercept of 1, I'm going to count up 6. 1, 2, 3, 4, 5, 6. And then I'm going to count over 5. 1, 2, 3, 4, 5. And here's a point on my line. So the 6 is the rise, it's the up and down, and the 5 is the left, right. So let's see, what if I had decided to start at that point and instead of going, now my slope is positive. So I went, let's think about this, in the positive direction and then the positive direction. Positive 6 over positive 5 is positive 6/5. If I had gone down 6, 1, 2, 3, 4, 5, 6, gone negative 6, and then gone negative 5 in the negative direction, 1, 2, 3, 4, 5, I'd still end up along that line. Negative 6 divided by negative 5 is still the same as positive 6/5. So it doesn't matter. Sometimes we run out of room on a graph. If I had wanted to keep going, I went up 6 and over 5 to get here. I could go up another 6, 1, 2, 3, 4, 5, 6, and over another 5. And I should end up on that same line. Those are called collinear points. So first thing we do is we go to the y-intercept, and then we do the slope. Now the other thing I want you to take away here is that we can write the equation of this line as well. The equation of the line always goes y equals slope 6/5 times x plus the y-intercept. There's the equation of the line. So if I was given the equation of the line, I could also graph it. Let's try a couple more of these. It says graph the following features. We have a y-intercept of 4. So I'm going to go on the y-axis up to 4. And now my slope is negative 1/2. So I want a negative 1 over a positive 2. Or I could do a positive 1 over a negative 2. One of those things should be the negative direction. Remember, positive is up and to the right, negative is down and to the left. So from that 4, I could go up 1 and 2 to the left, up 1 and 2 to the left, up 1 and 2 to the left, and we can start to see what that line looks like. Or I could go, if I go back to that 4, I could go down 1 and 2 to the right, down 1, 2 to the right, down 1, 2 to the right. And you notice all of those points lie on the same line. They are collinear, we like to say in geometry. Our equation there would be y equals the slope, negative 1/2 x plus 4. Things to keep in mind: if it's going uphill, positive slope. If it's going downhill, negative slope. Okay? Here's another one. Y-intercept is 1. In this case, the slope is -2. Well, that slope, again, should be a rise over a run. Our rise is -2, but we turn an integer into a fraction by putting a 1 underneath it. So I'm going to start at that 1, and then from there I'm going to go -2 and +1. So down 2 in the negative direction and 1 in the positive direction. Down 2 over 1, down 2 over 1. I continue that pattern. Or I could have gone up to -1 in the x direction. So up to 1 to the left, up to 1 to the left. Doesn't matter, all those points end up on the same line. Our equation there would be y equals -2x plus 1. We get the hang of this, not that bad. Now we're going backwards here. I've given you the equation. Let's draw the line. So I didn't give you the specific things. I've given you the equation. So this tells us our slope, that number in front of the x, our slope we call m for some reason, is -1/5. And our y-intercept here is not 3, it's -3. We call that b for some reason, -3. Our general equation is y equals slope times x plus y-intercept, mx plus b. All right, so again, I start at the y-intercept. That's -3 in this case, so I'm going to go down to the -3 on the y-axis. And my slope is -1/5. I know my line should be going kind of this way. So I'm going to go down 1 to the right 5 and put a point. And I should keep going. I'm going to do that a couple more times. Down 1 to the right 5. Or I could go up 1 to the left 5. Up 1, 1, 2, 3, 4, 5. And there's my line. Again, all those points, because of that constant rate of change, all those points lie on a line. Now, in this case, we're asking for, I forget if the question was give the slope or give the equation of the line. But what I want to look at here is I want to find the slope. I can see the y-intercept is 1. So if I'm giving the equation, it's y equals something x plus 1. I need to find that slope. Well, I want to look between two what we call corner points. I don't want to look, for example, like right here. It's not on the corner of that grid. I don't want to use that point, but let me find 2 points that are on corner points, like maybe right here, and then maybe right here. And I'm going to count my slope. What's my rise? What's my run between those 2 points? So I'm counting up 1, 2, 3, 4, and I'm counting over 2. And because it's going to the left, and because the line's going down, my slope's going to be negative. So -4 over 2, which is the same as -2. Some of these questions in Delta Math ask you for the slope. If they ask you for the slope, you're going to give this, -2. If they ask you for the entire equation, you're going to give y equals -2x plus 1. I think you could do -2 over 1. That's okay. X plus 1. Just a note here on the slope, because that rate of change is it's a constant rate of change, I could choose any 2 points, any 2 corner points. Like say I went from here to the y-intercept. I'm counting up 10 and over -5. Well, that ratio, 10 to -5, it's still the same thing as that -2. So it doesn't matter how we count those out. As long as we use corner point to corner point, the rate of change is constant anywhere on that line. This one, again, I think they're asking you for the equation of the line in this case. But again, we can see the y-intercept is -1. What I need is the slope. So let me see, from here to this point, if I count up and count over, counting up, that's 6 units, and over 5 units, my slope would be 6 over 5. It's positive, it's going uphill, so it's positive 6 over 5. My y-intercept is -1. If they wanted the equation, I could say y equals 6 over 5x minus 1. Okay, so it's little things. They take some practice. Work on them in Delta Math. Let me know if you have questions on any of the particular sections. All right, work on that today, please. Take care, guys. Bye-bye.